All right, everybody, it's Miss Marine, and I'm back to talk about the second half of measurement conversions using metric units. So you would think metric units would be simple because, as you see here, all the numbers are hundreds and thousands, tens, hundreds, and thousands. It's a base 10 system. It's made to be mathematically easy. It's a system that scientists use, that doctors use, that the entire world uses. We're the only country that doesn't. So because of that, students are not real familiar with using centimeters and meters. They might have a decent reference for those two, but for what does a kilometer feel like? What is a kilogram? We just don't have those references here because we don't use them. So they don't really have to know about them and have great personal references. They just have to be able to convert among them. And luckily for us, that is a pretty easy thing to do because it's all based on decimals, which we've learned how to do. All right, so for 3 meters, if we want to know how many centimeters there are in 3 meters, again, I don't have to memorize that. It is here, but these prefixes, centi, 100 cents in a dollar, 100 years in a century, so 100 centimeters equals 1 meter. So just like in our last unit, we're going to be multiplying to find these smaller units. So 3 meters, I need to know how many centimeters in a meter is 100. So 3 times 100 is 300 centimeters. 8 kilometers is equal to how many meters? I have to know how many meters there are in a kilometer. Kilo meaning 1,000. 8 times 1,000, it's going to be 8,000 meters. All right, then we're going to work with some decimals here. So 4 and 2/10 meters. Well, if 4 meters was going to be 400 centimeters, 2/10 of them is going to be 2/10 of 100 centimeters, so 20. So again, if 4 meters is equal to 400 centimeters, and 5 meters would be equal to 500 centimeters, then 4.2 is going to be equal to 420 centimeters. All right, and then 75 centimeters is equal to how many meters? This one's actually working in reverse, so a little bit of a challenge here. Again, you have to know that there are 100 centimeters in a meter. But we only have 75, so it's not even 1. So if 1 meter is equal to 100 centimeters, and I only have 75 of them, I'm going to have less than 1. Well, how do we show less than 1? Using hundredths. We already learned that with decimals. So it would be 75 hundredths of a meter. Or 100 centimeters would be 1 full meter. All right, those are all for metric units of length. And then we get into capacity. Not much to know for capacity. 1 liter is equal to 1,000 milliliters. So 4 liters is going to be 4,000 milliliters. 5.3 liters, or 5 3/10. So if 5 liters is going to be 5,000 milliliters, 6 liters would be 6,000 milliliters, and 5 3/10 is going to be 5,300 milliliters. In 5th grade, they'll work a lot more with just sliding the decimal, moving the decimal left and right a certain number of times. 10 times as big, 100 times as big, 1,000 times as big. We're not going to do that. We're going to try to just keep it pretty simple. There won't be a whole lot of questions on metric conversions on their test. As long as they're able to basically multiply by hundreds and thousands, they should be okay. You might see some of these, maybe not. I like to expose them just in case they see that and they have an understanding of that. Just like with our customary units, we used a table last week, so this sometimes helps students to see, okay, my milliliters are always going to be 1,000 times as big as my liters, and then anything that's going to be a decimal point or anything that's got like a whole number that doesn't end in 1,000, then that sort of helps me out with a reference here. So this is 836 milliliters. Where does 836 lie here? Okay, not even 1 full liter, so this is going to be less than 1 full liter. This is going to be in thousands, which we haven't really worked with, but 0.836 or 836 thousandths of a liter is what 836 milliliters is. Okay, again, just a challenge question, not something I think they'll probably need to do. All right, and then the last one is weight or mass, knowing 1,000 milligrams is a gram and 1,000 grams is a kilogram. All right, so 2 kilograms, 2 times 1,000 is going to be 2,000 grams. This one works backwards. This is now 6,000 grams. So again, Nice thing about working with all of these metric units is that the prefixes basically help you out with understanding. So the liters and milliliters works the same as the larger one here is kilograms and grams. So if I did 6 kilograms, it's going to be 6,000 grams. So I'm just working backwards here. 6,000 grams is going to be a division by 1,000. It's going to be 6 kilograms. All right, and then we're going to do a couple days of what's called mixed measures. And this involves, back to customary here, but sort of an application of using addition, subtraction with these different measures. So if I was looking at units of weight, let's say I had a kitten and the kitten weighed 2 pounds, 8 ounces. And when I took the kitten to the vet for its checkup, it had gained 1 pound and 10 ounces. So how much does the kitten weigh now? All right, we'll line it up like this and the students can add and get 3 pounds and 18 ounces. But just like we learned when we worked with fractions, this goes over the whole. So this is going to need an adjusted answer. So if there's 16 ounces in a pound, then this is actually 1 extra pound. So we're going to make this equal to 4 pounds. And then how many extra ounces? Again, there were 16 ounces in a pound, so it'd be 2 extra ounces. And if you just add it straight up like this, you're going to see there's nothing wrong with this addition, but you're not going to find this as an answer choice on your test. You're going to have to convert that answer. All right, and this is different depending on how many ounces, or depending on what type of a unit you're working with. You got ounces and pounds. This one here shows inches and feet. So in this case, we're working with addition of length. So let's say I had a board and it was 2 feet and 6 inches, and I wanted to nail another board next to it and increase that length, and that board was 2 feet and 9 inches. If I add those together, 9 plus 6, that's 15 inches, and 2 plus 2 is 4 feet. So 4 feet, 15 inches. So this goes over the whole. Remember, the whole here with weight was 16 ounces in a pound. The whole here with inches is 12 inches in a pound. So just like with our fractions, your whole can always be different, your denominator is always different, same thing here. So we're going to adjust this into a better answer. So 12 inches is an extra foot, so I'm going to bump this up to 5 feet, and then there'd be 3 extra inches left over. All right, another one for length. Let's say I had a piece of wood that was 5 feet 3 inches, and I cut some away. I cut away 2 feet 10 inches. How much of that board is left? Well, we're going to do a subtraction here. First thing you need to notice is that when you only have 3 inches of something, you can't take away 10 inches from that. So we'd have to do a regrouping. Just like with our fractions, we're going to take 1 and we're going to give, but we're not giving 10. It's not take 1, give 10. It's take 1, give a whole. So I'm going to take a foot, turn this into 4 feet, and I'm going to give a whole foot over here. A whole foot here is 12 inches. So I'm going to add 12 inches plus 3 that's here and give myself 15 inches. And now I can subtract. 15 minus 10 is 5 inches, and 4 feet minus 2 feet is 2 feet. So 2 feet 5 inches is the difference, and I can't just take 1 and put a 10 over here or add 10 to make 13 because there aren't 10 inches in a foot, there's 12. So again, just relate it to what we did with fractions, and that should make it pretty easy. All right, that'll do it for measurement. Remember, we're working with customary and metric, and students do not have to memorize all of these, but they do have to be able to know how to use this chart using multiplication in almost all of these situations. All right, thanks for watching.